Welcome, welcome. Happy Wednesday. Thanks so much for joining us. I am so excited and honored for today's session. We're going to be hearing about Michigan's first net zero home. And while I introduce our speakers that are joining us today, if you want to say hello in the chat and let us know where you're joining us from, anything that was exciting from your weekend or what you're looking forward to the week ahead. I'm going to introduce Dale Hulst from Michigan Net Zero Homes. Dale is a licensed builder, a PHA certified passive house consultant, and a former HVAC industry innovator with over 40 years of construction experience. He holds multiple patents for energy saving technologies developed during his 30-year career in commercial HVAC, and now applies that to deep technical expertise in pioneering net zero passive house level residential projects in Michigan. Through Michigan Net Zero Homes, Dale is advancing high performance, low carbon construction with a focus on resilience and innovation, all while staying active in community climate initiatives and advocacy. We also have Kristen Cora joining us today from Climate Adhesive. Kristen Cora leads strategy and outreach for Climate Inc., a company manufacturing next-gen adhesive design to mitigate damage from seismic and high wind events. With a background in international democratization and military intelligence, Kristen brings a global systems thinking approach to climate adaptation and resilience. She is a passionate advocate for early adoption of materials and practices that strengthen buildings and communities against the growing risks of climate change. This is a really, really juicy one, so buckle in because we're going to be seeing a lot of construction photos, details, and really diving into the fun, nitty-gritty, geeky stuff that we love. Dale, please share your screen and take it away. Thank you.
Super. I am super honored to be here and excited about presenting here today. And here is the prezo. Hopefully you're all seeing it.
Looks
And
good.
this is the house maybe a couple months ago under construction. You can see the vented rain screen system there under the LP Smart side. And we're going to take a deep dive into kind of how this came to be and what we're trying to do to get to what I'm calling comprehensively net zero. Oh, shucks, I'm not advancing here. There we go. So the title for this presentation was Net Zero When? And when do we want net zero? We want it now. So trying to move as quickly as we can toward that and just do it. Talk a little bit about how I came to be in the spot after 30 years in commercial HVAC. Some innovations in the house that the foundation in particular is pretty unique. And then go through some little bit more normal passive house best practices with the survivability piece there being pretty innovative also. And then take a look at this all from a life cycle cost analysis perspective. So a little bit about me. As I retired here in 2020, I started the process of retiring, and I spent a little bit of time with a pastor, counselor from my church, and walked through Enneagram and skills and values and the book Let Your Life Speak by an author by the name of Parker Palmer. And the goal of all that was to come up with a mission statement, and you see it there in yellow at the bottom. I learn and create in order to help people live sustainably. And that helped me focus a bit because I'd been doing some climate advocacy work since about 2017. And I'm okay at it, but I'm not the world's greatest salesperson. And I'm better at just doing things and creating things. And so that helped me kind of focus where I wanted to go. And so that kind of did some roundabout meanderings and led me to form the business, Michigan Net Zero Homes, beginning of 2021. Somewhere along the line there, I got certified with Green Home Institute. I had watched a lot of their webinars, just learning what the landscape was in the green home business. Got certified somewhere in 2021, and then end of 2021, signed up for the PHA CPHC classes, did the design exam, end of the year and earned the certification beginning of 2022. Thinking I'd be just a consultant, and then ended up um, with a consulting project on a beautiful brick house in a beautiful neighborhood here in Grand Rapids, and met the architect who ended up partnering with me on this house. And I just wasn't confident that I could tell them to tear the brick off and redo the envelope on this house, and decided I really needed to build a house, to apply what I knew, what I had learned, and really learn the ropes of passive house. So I started off this process with some kind of naive desire. Let's make it comprehensively net zero. Some partnerships that were important. FIAS being very important, Green Home Institute, Corey Sandwick Architecture. I hired early on, which was it has been invaluable. She knew how to work with the local planning people and run some of my crazy ideas by them months ahead of actually seeing the official plans. So some important partnerships to get started. Eco Achievers also in out of Chicago, Ann Arbor, is an important partner also in making this all happen as the rater on the project. So um, my as I looked at the landscape, you see net zero ready and things like that. And in my advocacy work, I've seen people talking about goals, net zero by 2030, net zero by 2035, and no game plan of how to get there. And so in my mind, you got to kind of stage this out. Saw Griffith's book, Electrify Everything. We got 1 billion machines in the US that need to be electrified over the next 30 years. We need to start with the new stuff. If we can't build the new stuff net zero, how are we ever going to get all the existing buildings retrofit to net zero? So it seemed to me that it was kind of that's the place to start. Let's figure it out on the new buildings. And then some of you I know are already figuring out how to do the renovations, but frankly, renovation's harder. And I wanted to start what seemed a little easier. Um, so yeah, wanting to get to net zero now. So first innovation was to design the house on a narrow city lot. It's a 50 by 175-foot lot, and design it as a kind of a long shotgun house, and optimize that roof so that I've got lots of south face with enough solar to power the house and 2 EVs. I got certified with Solar Edge Designer at 1.2, so I could run preliminary runs on the solar and kind of play around with the roof size and the profiles to get that to work right. Also decided to set it at 12-12 so we can shed snow a little better in the winter, and also optimize winter production. And then, of course, using some passive house principles on those south-facing windows you see in the lower drawing there. So some innovation there, but something I'm sure others of you have thought about too as you design a site and the roof line on the house. But I think it's important. Let's not ruin that roof when we have a chance to get it right for the next 100 years. Let's set it up for success for solar. So second innovation is really has more of my fingerprints on it. I spent multiple hours sketching and playing with ideas of how to get to a concrete-free, foam-free foundation system. And I combined 3 rare ideas to get to this, and put it all on a base of foam glass aggregate. This was something I would do again. I would do it a little different. I have 2 different levels here. You can see the footing sitting on the foam glass aggregate down here and then sloping up. That caused some issues. You'll see, I'll describe it a little more in an upcoming slide. This bottom picture here is the geotex over the sand, radon, passive radon system around it, and the drain pipe around that. But the goal was to be not just net zero operational, but net zero embodied carbon. Here's the foam glass aggregate going in these 3-yard super sacks, getting compacted. This is the part I wouldn't do again, was these 2 levels. We had lots of struggles fighting with this slope, and the stuff would roll down. And then when we started putting our footing in, it would roll down under the footing and cause us some grief with trying to get the footing nice and level. And so next time I would just do it all flat. and fill it with more pea stone, which you'll see in this next slide. So here's the wood foundation going around, and 2x6 inside, 2x4 out on this treated plywood and 2x8 base, glued and screwed together, glued with climate adhesive, which we'll talk about more in a minute. And as we built that up, then we filled it with pea stone, 6 inches in the main floor, the slabless slab area, and then filled the footing up on the outside. So there's 50 tons of pea stone in here. Had we just made this flat across, we'd have had probably 100 tons in there, but I think it would have been a simpler way to build it, and pea stone's pretty cheap. Um, so yeah, we screeded the pea stone across the footing. We put some screen in here. This darker color here is a fiberglass insect screen that we use to keep the pea stone from getting into our tongue and groove plywood here. We had 2 layers of tongue and groove southern yellow pine plywood that we glued and screwed together, again with climate adhesive. So those 3 rare ideas, the shallow frost protected foundation, the wood footing system, and the slabless slab all on that gravel base is probably the most innovative thing in here. And as far as I know, the first one that's been done in the country. I did get the idea from, I got to give some credit to the folks on the Building Science and Beer show. I believe it was Mike Gurton had a little sketch he held up at one point in a webinar they did maybe 2 years ago. And it's like, that's it. That's what I'm going to do. So I took their idea, modified it a bit, and put it on this foam glass aggregate base. So into more typical best practices when you're trying to build low embodied carbon, use natural insulation. I chose timber fill and timber bats from Timber HP out of Maine. Very happy with the product. I know they're kind of struggling with some financial, getting to the next step to do their timber board right now, but I would use them again, assuming they can financially pull through a Chapter 11 reorganization. I understand they're going through, but good product. Really happy with it. We've got 13 inches of the dense packed in the main wall cavity, and then plus 3.5-inch bats in the inside service cavity. Makes for a very quiet house. And it sequesters about 8 tons of carbon in itself, weighed about 12 tons. So 12 tons of insulation in the house is just kind of an interesting number to know. So we built this house. Here's a cross section of it with this shallow foundation. And it's pretty narrow and tall. So there was some concern initially about shear strength of this end wall. We did end up putting plywood on the end walls. The main walls are it's a sheathingless design that I got from 475's assembly library. It's their tier 3 double wall assembly. And decided we have ground screws. So basically everything's fastened together. So the goal is to make this less vulnerable to wind. How do we get there? We fasten everything together with continuous connections from the ground to the roof, following the ideas from the Insurance Institute for Business and Home Safety, IBHS, has a fortified standard that I checked into a couple years ago. Wish I'd have found somebody to certify it. I made one call to the one person who was listed in Michigan, and he said, I'm not doing that anymore. Just kind of build to the standard and don't certify. Well, I wish I would have chased a little harder and actually gotten it certified, but I didn't. So we'll do that on the next one. But anyway, you can see here's our ground screws going through that footing system. They're about 46 inches long, go through the foam glass aggregate down into the sand. There's 16 of them around the perimeter. And again, everything is screwed with stainless steel GRKs, truss screws. In addition to normal nailing, also use blocking truss up in the attic truss up here. There's blocking truss between them, gives that a bunch of stability and more ability to fasten it down. And everything's got lots of adhesive in it, which is where we can pivot to Kristen here. Yeah, we used it everywhere in the building under our subfloors, under truss, throughout the building, and it significantly strengthens those connections. So Kristen, go ahead.
Yeah, sure. I don't know if you want to advance the slide. But yeah, Dale heard a webinar on Green Home Institute, which we gave, and he just like I think during the webinar ordered a case, like just fearlessly willing to go where innovation, proves itself to be viable. So hats off to Dale for, helping create this beautiful, beautiful case study. I've been there a few times and it's just an amazing space to be in. And Dale's an amazing innovator. So he put it under plates, subfloors, sheathing. I mean, it's intended to act like a monocoque system and give that continuous load path. And the secret sauce, if you will, is its ductility. That's why adhesives are not allowed in code right now. We are going to change that, work hard. I am personally working hard to change that so that people understand that there's a new capability in the vertical to um, disallow the embrittlement that a urethane has done in the past, and that's why it has been disallowed in the past besides in a subfloor application. But because we have up to 1,000% elongation, we try to hit that sweet spot, and we achieved it in lots of different testing of being both very, very strong and durable, but also incredibly ductile. And that's the new part that we're going to get into code. So um, Dale built over fortified because he also incorporated us throughout the entire outer envelope of the building. So if you want to say anything else, Dale, about that, please.
Yeah, it's been great working with you're an hour south of Grand Rapids in Kalamazoo, Michigan. I like working with a local company that's also innovating something new. And it's been great having support from your team along the way. We did the 2 layers of tongue and groove plywood in the floor. At one point, we had to take one layer back off to get some thermal break insulation in where the two outside doors go. And it is a bugger to get apart because it's so ductile. Um, Anything you do with it, the adhesive, you just kind of like squish it like rubber would. So we ended up using like a oscillating multi-tool to like kind of cut the 2 layers of plywood apart, just kind of mowing our way through the adhesive. So anyway, just a quick story of how tough the stuff is. Um, and it's zero VOCs, so it's healthy and uh, just a lot of good features about it. So.
It's non-toxic, so both the handler as well as the end user, won't have to worry about that whatsoever. California Prop 65 compliant, all the rest. So we're very, very proud of that. We want to help continue and grow the do no harm ethos within the construction supply chain generally, and certainly within the passive house vertical.
Yeah, just one other thing. I'm a data geek, so I did check out your videos. Or maybe one of your people sent it to me, but there was a video of the testing at Western Michigan University. So anyway, just nice to see that it's not just claims, but there's been testing done and such. So
Well, goodness, yes.
um,
We're in the middle process, like I said, of getting into code. Before that, we're doing our ICC ESR, sort of the gold standard for all structural engineers and architects. So there's not going to be any question about, anything whatsoever, but there is a wealth of information. Anybody who wants to geek out about load and kips and all that, because we do apply to a shear wall application as well as uplift. So we mitigate against seismic as well as violent wind events, which unfortunately more and more of America and the globe is becoming, subjected to and vulnerable to. So we wish we weren't so relevant, but we're here.
great, yeah, and excited to be using it and pioneering it on this project. So thank you.
Thank you.
Another thing I would consider a best practice, I thought about, so when I first looked at all this, I thought, do I want to certify? And there's this, when I started watching Green Home Institutes, there's this alphabet soup of different certification options out there in the world. And I thought, now I'll just build a good house. And then the more I got into it, it's like, no, I think I need to certify. I need the support from people who have been down this path before. And there's something about just the credibility that certification brings. So So I looked at ILFI, International Living Future Institute as well, just from a holistic, creating a beautiful space kind of ethos, and didn't decide to do that. This house is LEED Platinum and Green Star Platinum as well as FIAS Zero. So I've already got a pretty good list of certifications to chase. So I didn't chase it, but we are doing native landscaping per this plan. And I've got some pictures I could show if there's time at the end too of landscaping is going in right now. And I've been surprised at how good it feels to see plants going in around the house and trees and little shrubs. And it's just, and uh, it really makes the house. But anyway, a lot of you know this already, but it just surprised me as being kind of a energy and construction geek, how much the plants felt good going in around the house. So anyway, there's a picture actually of some of the stuff going in. We've got a pretty significant slope on the front and in the back at the back alley. So I ended up hiring a landscape architect to design some of the details with that and the plantings. We have a rain garden on the south side here. So here's our dogwood, and it flowered. So that was kind of fun. It just went in like 3 weeks ago. But anyway, um, and yeah, this is a little more complete than the first pictures you saw. We still have some siding details around the front door here to get in. So just quickly summarizing, how are we doing on time? I think we're doing okay. I'll kind of run through this quicker, pick up the pace a little bit, but just kind of the recipe for the house, kind of at a high level spec level. You can see our 59 walls, 94 roof, 36 floor with the foam glass aggregate down there. It's a double membrane system. Intello is the primary air barrier on the inside double wall. It's on the exterior side of the interior double wall. So it's protected from people ever putting nails, hanging pictures and that kind of thing, which made a lot of sense to me. Those membranes are extremely valuable, and we spend a lot of time detailing them, and you want to protect them. So the Mento on the outside is a vapor open and water resistant barrier, and that's protected by the rain screen on the outside. We talked a little bit about low embodied carbon design already. I got a slide coming up where you can see some of the beam calculations on that. I used Alpen, quad pane, tilt turn windows. They're all operable. Finishes, tried to pick everything. As far as I know, I succeeded. It's so much work to look at all these details as you go. But trying to pick red list free materials, and net zero materials when possible. We're using a Milestones net zero tile, Yorktown maple cabinets that are domestic, decked in countertops. They come from Spain, which I don't love, but it's a net zero product for countertops. And Benjamin Moore paint. The LP Smart side is got lots of adhesive in it, which I don't love, but it's a decent product from an eco standpoint. Here's the appliances and HVAC. Little 1-ton Mitsubishi heat pump. I did go with a Sandon monoblock heat pump water heater. CO2 is the refrigerant in it, which I think is fantastic. I think that's the future. I'm a heat pump geek. In my former life, we converted rooftop units into heat pumps in our shop. We did custom kind of work in our shop. So I'm pretty familiar with the details on heat pumps and low ambient heat pumps in particular. Using a Zender Q450 with the boost switches and the humidity input and the CO2 input. So I should have a very intelligent ventilation system, Bosch appliances. And then, of course, the solar system, we went with Enphase with Meyer Burger panels, 32 of them on the roof, 40 kilowatt hours of battery, two 9.6 kilowatt EV chargers in the detached garage, which we haven't started building yet. The site kind of precluded building the garage because we had to get equipment down onto the site as we went. So it's almost like a second project that will follow. I probably have an excavator there next week, so we're getting close to doing that. And I wanted, in the worst way, to do vehicle to home or vehicle to grid would be better yet. And Enphase had announced the product 2 years ago, and they still haven't, they still aren't shipping. So I'm doing what I'm going to call poor man's vehicle to home, putting a 30 amp generator plug in the garage. I happen to have a Ford Lightning that I've been powering the job site with, including a temporary heat pump. Um, and um, yeah, it works well. It's quiet too compared to running a generator. It's awesome. So um, and anyway, so I'm putting a 30 amp generator plug in there, which is 7.2 kilowatts of power that will go into the Enphase system if needed, um, in a situation where you wanted to also use your car battery. So I've got span electric panels, two of them, one in the house, one in the garage. And at this point, still planning on a consumer's energy interconnection. I'm a believer in the grid for grid load and generation diversity helps us. And helps us be more efficient with resources. So in general, I believe in the idea of having a grid. I'm extraordinarily frustrated by the interconnection rules here in Michigan right now. I might not end up with panels on my roof till after the house is done, which is uh, crazy from a project management standpoint. So anyway, that's kind of the high level recipe. And wanted to spend a little time on thinking about costs, because I mentioned the word, I went into this with some naive desire at the beginning. One was on costs. I thought I would build a modest house. It's 1,510 square feet, in a modest neighborhood. There it is between the neighbor houses, and it looks small in this view. It's kind of a wide angle view. Um, uh, it's in a neighborhood up here, where the houses are probably 300,000 tops. And there's a few more expensive houses within a couple miles, but this is definitely an apple that we're trying to not directly compare with oranges, or at least to really show a potential buyer why this house is worth $1.4 million. So that's probably my biggest challenge is I built this house kind of the way I'd want to build it if it were for myself, just quality stuff everywhere I go through the process. Um, and it's ended up costing double what I had imagined it would at the beginning. Um, so I made an attempt here, and we could go way in the weeds here, so I'll try to go fast, but just to think a little bit about how do you quantify the value of a house like this? So I got a few different buckets here. The easiest one are the hard savings, the energy savings, which amounts to about 4,800 bucks a year and saved fuel both for vehicles and for the house. It's 120 grand over a 30-year mortgage. That allows a little bit for maintenance. If you had a 100-year at least minimum life, the membranes are rated for 100 years. Um, and maybe it's a 300-year house. We don't know for sure. But that's the easiest thing to quantify, is to add up those energy savings. There's also risk avoidance, which we've already talked about with the winds. And um, these numbers that as we go here, and they're less solid numbers, I've actually built a little spreadsheet where I could potentially sit down with a potential buyer and kind of run through, hey, what's this worth to you? How many dollars a year is it worth to you to have a house that's going to stand up to wind much better than your neighbors would? So and the house should not form icicles. It just shouldn't happen. It's a vented roof deck. It's got R94 insulation in the roof. It did not form icicles this winter. The steel roof's been on since November. I didn't have the house fully heated through the winter. I had some heat in it, but so it wasn't a perfect test, but I'd be amazed if it formed any icicles. And like all passive houses, it will hold heat for days in the event of mechanical problems. In our case, we go home on the weekends, the truck's not there, so the heat pump doesn't run. Um, and it's dropped 5 degrees by Monday. So we know the house holds heat. It's pretty amazing. So this slide here, it's kind of an unassuming slide in some ways, but it's really the motivation of why I did the house. Uh, I mentioned I did some advocacy work. I think policy change is a huge lever and one we all need to be thinking about how we can influence that. Um, but this was a way I could directly try to reduce the emissions of somebody's life who might buy this house. And it ends up being about 14 tons a year in operational emissions that are reduced. That includes the vehicles. And that's about 2/3 of the average American's carbon footprint. The house energy use plus vehicles is like 2/3, and what's left is what we eat and stuff we buy. And if we fly a lot, that's going to add to our footprint, obviously, which you can buy offsets for if you want to. So I'm trying to help somebody get to a net zero way of living. 35 tons of upfront reduction. That's worth 45 grand over a 30-year mortgage. And that in some ways doesn't sound like a lot, but it's 45 grand of damages to other people in the world is how I think about it. And damages to their livelihood, damage to their lives directly. And so maybe it's more than $100 a ton of, and again, this would be something someone could maybe value it more than this or less than this, and could stick that in a spreadsheet and turn it into a life cycle cost analysis kind of thing. But anyway, this slide is meaningful to me, and that it's really the reason I set out to do all this. So here's the embodied carbon details from the beam calculator. And I should probably minimize that. And yeah, we're at about 24 tons. The house and garage is built. The garage is over 1/3 of that. The garage, unfortunately, needed to have conventional cement footings and frost walls in it. And I cannot find anybody in West Michigan who will sell me low carbon cement yet. Very frustrating. I've spent quite a few hours digging around and come up empty. A more conventionally built house would be more like 59 tons. This same house built more conventionally. I did use a paper-based cellulose, and in this analysis, this number would be worse yet if it were fiberglass, and much worse yet if it were foam. So the cement's probably the biggest reduction you get, and then the next biggest one is not using foam. So anyway, there's the details on that. It's a great tool. It's simple to use. If you haven't run into it, it's worth looking up. Builders for Climate Action out of Canada, and that's called the Beam spreadsheet. It's a Google sheet. So the house is going to have super fresh filtered air. I'm putting a MERV 16 filter. I believe that's a Green Star Platinum requirement. And I'll provide them a meter to watch their PM 2.5, their radon, their CO2, their VOCs. The houses, all passive houses, will be comfortable. There won't be any drafts. There'll be no condensation on windows, therefore no mold on windowsills and that kind of thing. We've reduced the chance of radon through the passive system, so the lung cancer risk is reduced. We've used non-toxic materials like we talked about. We use low maintenance materials like the metal roof, the LP siding. Both of those are 50-year systems. The deck and countertops are a 25-year system, I believe. The hardwood floors are a 30-year warranty. And it's got stone strip around the outside that keeps splash off the house. Windows are all operable. There'll be less bugs and less dusting than a normal house. So. And you've got energy resilience and independence, with things we've talked about already. And here's my little quip on this. Let's say you've got a grid down event, and let's say that the sun's not shining because it's January and it's cloudy and here in West Michigan, and the batteries are getting low. You could, call up your spouse and say, "Hey, honey, the grid's down. The grid's still down. Could you pick up 30 kilowatt hours of power on your way home from work?" And you could plug in and power the house for another day or two from the vehicle. So this house is really close to being able to be off grid. And in fact, if you are willing to do this for December or January, you could be off grid just by taking your power home with you in the car. So anyway, I spent a lot of time thinking about going off grid, and really didn't quite make sense at the end of the day to me. So it's quiet, it's safe, there's no gas in the house, no chance of leaks or explosions from that. I have it pre-wired with coax and Cat6 to the bedrooms and living room, and some provisions for bringing in future technology from outside into a little office area on the main floor. And this is the last slide, and then we can go to Q&A here. Purposely picked this lot close to downtown in what we call the medical mile, hoping that there would be a professional who works downtown, maybe a doctor who works in the research institute downtown, who might want to be able to walk or bike to work. There's 2 parks that are right close by within 2 blocks of the house. And just trying to make a place that would be a great place to raise a family. So that's kind of my attempt at a little bit of a loosey-goosey LCCA, but just to try to quantify some of the values that a house like this brings. And again, there's a spreadsheet tool. You could assign dollar values to these different things and say, yeah, this is worth X to me. So like to say your home's design is a key to living a net zero life. There's my contact information. My email is dale@minetzero.com. And there's my phone number. And I thank you for taking time to listen to me run through a lot of information. I know this is dense. So I'm happy to take questions.
Dale, that was perfect, both in the timing, in the content, and in the inspiration. I mean, like, you are just taking everything that our communities are learning and teaching each other and putting it together in a package that shows people that it's doable and is proof of concept and is really, really inspiring, exciting stuff. Okay, we're gonna jump into questions. We got a stream of them. And first up, if Christina, you're still with us, you had a question about deconstruction. Christina, if you're not with us or can't ask your question, I'm happy to ask it for you. Okay, so Christina asks, does the adhesive make the material unusable in a potential future deconstruction situation?
Does it make what sorry?
Does it make the material, so as Dale was describing how he was, deconstructing the plywood
Sure.
that he had adhesed, is it a potential that it makes it unusable for deconstruction, like if you're looking to design for deconstruction?
Yeah, I mean, we designed it for absolutely for durability. So there's no like chemical antidote or anything like that. So if you have, partial destruction or something, you're just going to have to get surgical with a Sawzall, and then rebuild with it, because we build for, like Dale said, there's no durability test that has, tested out the durability of our adhesive. So we build for 300-year-old homes too, Dale. So yeah, there's no sort of end of life that isn't, just, if you get a tornado or a hurricane that's strong enough, of course, it's going to destroy, the home completely. And we haven't, been able to get in a wall of wind situation where we have been able to do that. We've done 8x8 wall specimens. We've broken loads and dozens of those to get years of testing that we do have. But again, if you do want to do rebuild part of a building, et cetera, you're going to have to, get surgical with a saw.
Yeah,
If that answers the question.
that makes a lot of sense. That's the point of the product. And so if someone's designing for deconstruction, they should design smartly around how they're placing the joints and
Absolutely. So
yeah.
if you want to do it in some sort of modular way, but yeah, we're built for durability and ductility is the point.
Yeah.
Thank you.
Thanks. And Shannon, you're up next.
Awesome. Can you hear me okay?
Yep.
Great. Yeah, I have to add to that just because I've become very familiar with the product and very impressed with the product, because it does something that no other product in its category can do. And Kristen helped me understand that when you're gluing your framing together to get increased durability during high force winds, they don't recommend gluing your framing at the sill plate to the foundation, because The point is to allow it to survive that high force wind and stay in place. But if the winds are such that it is going to rip the building off the foundation, if you glue this sill plate to the foundation, it will break the foundation first. And then you won't be able to reuse the foundation. So if you don't glue it down, then, if the house is going to disappear, it disappears, but then you can reuse the foundation. So I thought that was a really cool way to future-proof the ultimate disaster scenario.
Yeah.
My question for you, Dale, not only is your presentation fantastic, but the project is just absolutely delicious. So thank you for sharing it. I noticed your quad pane windows from Alpen, and I wonder, did you model it with triple pane and need to go to quad to certify, or did you do it for durability or another reason, or sound, or?
Good question. Yeah, I started with triple pane and didn't make the winter heating demand criteria. So it's because it's a narrow shotgun house. So I end up with a lot of, and because the foam glass aggregate under it also makes the envelope taller. So
Right.
I've got quite a bit of square footage of envelope for the relatively modest square footage of floor. And yeah, I didn't make it, so I went to quad pane. I was not going to originally insulate the inside service cavity, the inside 2x4 on the double wall, and I had to insulate that as well. So we put the bats in that inside cavity, but that was in order to hit the winter heating demand criteria.
Great answer. Thank you. Great
Yeah.
job.
It goes to show, some people are saying, the FIA standards are not stringent enough. But certainly when you're going for zero, it's not easy. As Prescott pointed out, R94 roof is pretty insane. I have a quick question I'm gonna slip in, and then Lori Goldman, you're up next if you want to get prepared for your big question related to policy. So what is like the number one kind of biggest piece of advice, Dale, you would give for people looking to scale this approach either to more houses or maybe larger projects, right? You're talking about the surface to square footage to surface area. Is there something that you took away from this that we could learn and apply, at scale?
Yeah, great question. And I'm going to say I'm still kind of struggling with that, what the business model is going forward. And I might feel very confident and cheerful about it if I get a buyer who is happy to pay the price I've got on it right now. If I don't and I lose a bunch of money, then I really have to think about what the model is. And the pull would tend to be to do custom homes where you've got a buyer who is willing to, just wants what they want and you can build what they want. And that would be financially safer. I didn't want to do the first one as a custom home just because I wanted to be able to have control of all the variables on this one. So as a learning exercise. So I think, is there advice for the next one? I would do the foundation system again with the changes I mentioned. Um, uh, I haven't done a deep dive on the financials yet compared to concrete. I'll get a little taste of that as I do the garage here with more conventional concrete foundation. But I think there were some advantages of doing it that way, and I just love not using the concrete at this point. So yeah, I feel like I'm rambling, but I don't know that I have clear advice yet. Hopefully I do in 6 months. So yeah.
Yeah, we look forward to hearing how it develops.
Well, and can I add that I think that the foundation is really, really, as you mentioned, Dale, like very, very important part of your LCA. And as we get, companies like Sublime that are committed to low, no carbon concrete production, the offtakes, are historic from Microsoft. That's very new development. But I think I really loved your idea about trying to get local concrete producers to at least a day, a month, a day, a quarter, somehow allow supply for people who do want to build to those new specifications that we have to start to demand. And, otherwise it's going to really be hard to scale. So.
Yeah. Okay, Lori Goldman, are you ready? Yes, there she is.
Sure. Thank you. I am not a builder. I am just a really concerned citizen about the future and how buildings are our biggest emitters after transportation. And so I'm with a climate group in my little town. We're working with the city all the time to get them to adopt a higher step code, but it's for a zero carbon step code, which BC has brought in. They brought it in last year, I think, or 2 years ago. And some cities are already moving to have no gas for air and hot water, and even stoves. But it's hard to get this city staff to recommend it. It's hard to get them because builders, even the building association says, well, you know, we got to wait for the builders to get on board. So it's very hard to educate the builders that to not put in gas lines is actually cheaper, and it's safer for the residents, and it's cheaper for the homeowner to not have gas, as gas prices will be going up. So I'm wondering how, if anybody on this call has any idea about how we can convince builders that not putting in gas lines is okay and is affordable, and how to convince the city staff to talk to council about it's not a scary thing, that builders can do this, and they are doing it all over the place. Any idea?
I'm just going to say my experience here doing this has been, I had a builder's license like 35 years ago and I let it lapse and then I got it back. Part of why I got it back is I initially tried to hire some subs to frame this house after we had it designed. I couldn't find anybody who wanted to do it here in the Grand Rapids area. It was just scared them off when they started seeing the double wall and the foundation system and whatnot. So I decided to do it myself. And basically, I think as a homeowner, you just got to say this is what it's going to be. Period. I had this in a little part-time job when I was retiring. I had a little part-time job at my church for a while, and I did some heat pumps there. And first question I'd get is, why are you doing heat pumps? Why do you want to do that? Because that's what we're going to do. So you just got to I don't know, you just got to tell them that's what we're doing, period. We're not putting gas lines in. So I think it almost has to start there where somebody's just saying, nope, we're not going to do normal here. And I think if your city doesn't allow that, then you need to get them to change the building code in your city to what I'm looking at in Grand Rapids here is, could I go off grid in the city? And I think I'd have to fight for a variance for that. And I might do that anyway, just for the possibility to be in the future. And so I don't know what that process looks like
Yeah.
of working with them on that, but
Yeah, in our province, the province has required no gas, furnace, hot water, and stoves by 2030. And some communities are already moving to that early because they've got to reduce emissions. And so it's that thing of convincing a city council and staff that this is okay. It's very interesting. Builders are very loath to change, I find.
Yeah.
And even though you give them lots of data or you give them information, there is that resistance to doing something better, even if it's the same price or cheaper. It takes less time. So it's very frustrating.
Laura, you're describing my entire life. We have a very innovative product that's very, very simple. I mean, it literally looks like this, but it's very, very high performing and low cost. Even though it's low cost, people still, if you have to add any extra step or any extra cost, then you have to really just get at the upfront cost versus the over the lifespan of the project value. If you put that in front of a homeowner for a 2,000 square foot structure, do you not think $1,500 of this is worth 300 times its resilience? The homeowner would say yes every time. So you need to drive demand from the homeowner simultaneously with educating that entire ecosystem of people who enable that project to incorporate something that is innovative. So it's up to us as a company to show the contractor that they can be the hero to their accountant as well as to their client with this innovation. So that's kind of what I aim to do, trying to do.
Amen. Yeah, it's educating all, like you said, all the people in the ecosystem. Douglas Massey, I see you're here and you're up next for question.
Hello. Dale, you went from an HVAC guy to being a builder and built a heck of a house. Like really incredible and great presentation. And obviously you put a million hours of research into this. Um, so how did the building officials look at your no concrete foundation and did you encounter any problems with that with the building officials?
I think thanks to my architect, Corey Sandwick Architecture, she had the foresight. She knew the people there. And as I started to develop this, I might have even been in sketch form. She took it down there, at least 6 months before we had the final plans done and said, hey, we're looking at doing this. What do you think? And so she gave me, and then there was another round. She did another round 2 months later. And then we presented them the final plans for approval. So the planning team had a chance to be familiar with it. We could point at the code. Shallow frost protected foundations are in the code. Wood foundations are in the code. The combination of the two with the slabless slab and the gravel was not in the code, so that's what they had to get used to. Apparently, the planning team in Grand Rapids, they took an extra week and looked at it, but we got approved. The code official who shows up on site, my building inspector, I've invited him out numerous times when I've got questions, just so he had a chance to see it and wasn't getting surprised by things. And he's been pretty much saying, I'm deferring to the planning team. If I see something obvious, I'll say something, but I'm not going to question the design because the planning team has reviewed that. So it's really gone well. And I think a lot of that credit is to my architect. So.
Did you use the gravel around the perimeter on the outside of the footprint of the house?
So the shallow frost protected foundation standard has kind of like a wing that comes
Yeah.
out. And so yes, there's a gravel wing that goes out 2 feet. It's continuous with the rest of the system underneath. And then there's actually 5 inches of rock wool on that as well, and 5 inches vertically against the
Okay.
against the wood footing. I actually had the rock wall inside the footing initially, and it didn't pass the FIA's hydrothermal analysis because the outside got too cold, that you got a condensation surface. So I ended up redoing the design and moving the rock wall to the outside of the wood foundation system, and that worked fine. I ended up finishing it with cement board on the outside, which you can see in some of the pictures. But behind that cement board is the rock wall. So.
And last thing regarding what Miss Lori Goldman was saying, yeah, nobody wants to change, and to get a builder to change, good luck. And I look at your project, Dale, and ooh, that's a lot of money. I don't know how much it was a square foot, but it was a lot of money. And that I agree, new construction is the way to go, but we got a lot of existing stock. But to try and get the price down to under 350 a square foot, and then the very last thing is I live in Beacon, New York, that has code that says you're building a new residential structure. There will be no CO2 producing things going into it unless you can prove a hardship. And that was brought about by local community organization presenting it to the town and the town adapting it.
That's great.
Yeah, yeah. That's it. I'm done.
Cool. Thanks for the comments.
Thank you.
Thanks, Douglas. Speaking of the cost and bringing it down, Tara Shankar with the $1 million question. Are you still with us, Tara?
I am, yeah. Hey, thanks for taking my question, and thanks, Dale, for this presentation. It's really fascinating, and there's a bunch of technical recommendations that I'll dig into, really juicy leads. I'm curious, so from what you've said, it appears that you took this on as a learning experiment, and I totally understand that. And we all take different avenues to learning. If you had to do it over again in terms of the financial approach to this project, would you choose this exact same site? Would you try to go for a multifamily? Would you do something that might provide a more guaranteed return? It seems like from a financial perspective, you took a lot of risks.
Yes, I have. And some of that was just being naive. Like I literally started off thinking I should be able to build something for 250 bucks a square foot. And then right away, Corey, my architect, said, I'm doing habitat houses for 250 bucks a square foot. You're gonna be more than that. So um, so uh that's what I have to figure out in the next 6 months is what the business model is for the next time. And I think if I were to pivot to, in effect, I didn't realize I was doing this, but I feel like what I in effect did is like try to prove to the world that I can build a high quality custom home, um, with all the bells and whistles. I got a heated towel rack in the master bathroom. So anyway, so I just keep doing, I'm doing stuff that I would like if it were my house, but it's way expensive. Um, so yeah, I got to figure that out. And in this, like I said earlier, the safest thing would be to put on my sign that I'm a custom home builder. If I'm going to do more spec houses, yeah, doing multifamily would make it easier to make the financials work, I think. So that's also takes more investment and a little more risk just because of the size of the project. So I don't know yet. If anybody's got ideas, message me afterwards because I need to figure out the business model if it's going to be a sustainable business. I have a sustainable house. I don't currently have a sustainable business. So
Yeah, it's really, I hear you. It's really, really tough to pull the ends together, both technically and financially, and from a zoning and allowance perspective. Thank you so much.
Thanks, Sarah. And we're at the top of the hour. I just wanted to say thank you to everyone for being here. Our speakers have been kind enough to stay on a little later. So if you still had a question unanswered, you are still up next. And we have Love Construction next in the queue. You still here?
Looks like they signed off.
Okay. The question was availability and importance of trades, crafts being local to ensure continued support of these high performing systems, question mark.
yeah, I think I used all local businesses. And yeah, I've had to do a fair amount of education with them of what we're doing. Some of the things aren't that much different. I've got a tile guy and a flooring guy there right now. That's completely normal. So um, plumber had a few things that I should have coached him on better. Um, the HVAC, the Zender unit, I'm doing with my own crew, other than the electrical and main ducting to it. And the solar company I'm using is our east in Lansing. Um, but they have a Michigan presence. So yeah, I think it's important to have people who can support the project. And I mostly use people right from the Grand Rapids area. If that answers the question.
Yeah, a bit of the subcontracting that went into it. And I'm thinking also long-term maintenance, right? Like who can service these systems? And it sounds like they're all local. Okay, we have a question from Chris Strange. Speaking of the HVAC systems, does the high MERV filter reduce the lifespan of the mechanical units? I've seen failures of HVAC systems when owners install really high MERV filters, freezing coils, burnt blower motors, trip circuits, etc.
Yeah, good question. And that is all true. In this case, I'm taking a little bit of a risk with the HVAC in that I'm doing a 1-ton mini split in the stairwell between the first and second floor. And I'm kind of counting on the insulation, the envelope, keeping things even, and on the ERV to kind of move the heat and cool around the house. In my CPHC class, I specifically asked about that, and I was told that should work. So I'm trusting that answer was accurate. So I'm taking so that's what it's just a mini split. So the filter is not in part of that. The filter is going to be part of the ERV system. So the Zender's got basically a MERV 8 filter in the unit. And then I bought a filter box from Zender that has a MERV 13 filter in it. That's upsized from what's in the unit. And then I needed to get the MERV 16 for Green Star Platinum. So I'm buying another bigger yet filter box that's gonna, in fact, I'm in the process of getting the adapter made for that to upsize from the Zender fitting to that. So I'm basically, the way I'm preventing overloading the fan motor in the Zender unit is by upsizing the filter. So on the pressure drop chart, it was down at like 0.1 inches or something. It was pretty negligible. So you can always reduce your pressure drop in your filter system by just upsizing. So that's the short answer.
Okay, so it's a not off the shelf kind of approach
Correct.
to
Yeah.
achieving that MERV. Great. Okay, and then we have our last question from Charlie Hatfield, who asks, what changes would you do that might not be as low carbon or as efficient, but brings down the cost closer to the market?
Great question. I debated on the steel roof, for example. It's at least double what it would have been to put shingles up there, maybe triple. But I have solar on my own house, and I made the mistake of putting it on a fairly old roof. I had to take the solar all off, redo the roof, and I personally put it all back on, drilling holes through my brand new shingle roof, which is not a good feeling. So what I liked about the standing seam is there's a clip called S5 is the brand name that clips the right onto the standing seam. There's no holes through the roof. So again, this is how I talk myself into better stuff. So, um, so it's like, why do I want to put solar panels on a roof that'll last 30 years and the roof only lasts 25 years? That's just stupid. I'm going to put a steel roof on there. And in this case, the steel actually, well, steel and shingles probably have a similar footprint, but and steel's recyclable, so you could argue maybe steel's a little better than shingles. But anyway, it was more of a decision about cost versus durability and performance than it was about carbon with the roof. Other examples, the siding, with LP Smart Side, I hired it out. So if I were to grow this business and have my own crew, my rule of thumb from my past life is that if I hire my own people, I can do it for about half the price of subbing it out. So if I were to build a sustainable business, I could cut some costs just by doing it in-house instead of having to sub everything. So that would help in general. That's just what my experience has been in the contracting world. Yeah, what else could I do to take cost out? I could not put $100,000 worth of landscaping in. I could do less battery. I could do a little 5 kilowatt hour battery instead of 40. That would be a 35 grand savings. And figure the vehicle to home system that I described would be enough to supplement that with the car battery. So there's a few things that could be done. I could buy a lot that was flat instead of big slopes in it. So there's some, rookie developer things that I've learned in this project too. So,
Well, we so appreciate you sharing your learnings honestly and transparently so that everybody can, take this and continue to further the mission. Which also great to hear your mission and how you're walking that talk. Thank you so much for everyone that joined. Thank you both to Kristen and Dale for staying later and engaging in this conversation. Much appreciated.